right now, what is happening is, let's see, in the lower left corner of this window, you'll see there's a number under next to the name progress. It's counting up 1 second at a time. 396, 398, 399, 400. That's in seconds. How many seconds have elapsed? That's the progress on an exposure that's going to be 1020 seconds in length. Where it says integration, and then in parentheses in seconds, 1020, that's the total integration time or exposure time for this exposure. So the silicon device is open to collecting light from the sky for that length of time. 1020 happens to be 17 minutes, 17. And we're doing 3 of those. So together they add up to 51 minutes. So 3 17-minute exposures is what we're doing. But what you're seeing are the controls of the telescope and spectrograph. This is being a telescope and a spectrograph. The telescope's job is to focus light from distant objects. In this case, the telescope is focusing the light from stars in the Andromeda galaxy. And you can see those white dots in the left frame, those in your magic window, Doug, you could see the stars, I guess. Yeah, those dots that you see with a dark square on one of them, each of those dots is a star in the Andromeda galaxy. So the Andromeda galaxy is a galaxy that's bigger than our own galaxy. And would it be helpful to explain what a galaxy is for the audience? And I have asked everyone to unmute, so please feel free to unmute and ask a question since it's a small group.
Yeah. If you're able to explain that, I think that'd be cool.
Okay. So everyone knows what a star is because our sun is the star that we are closest to. But our own galaxy is made up of not one star, but many, many stars. It's made up of a few 100 billion stars. So, oh, there we go. Rob has a picture of the Andromeda galaxy. Let me bring that up. Actually, Doug, you might be able to click on that. The chat. So the Andromeda galaxy is a collection of stars that is, there we go. And beautiful. Rob, did you take this image of Andromeda?
Yep, I took it. It was actually an early morning picture. I didn't have time to set up a lot of stuff, so it's just a 5-minute straight shot.
I see. Beautiful, beautiful. So the region we are focusing on, this Andromeda galaxy is, yeah, there, right, where Doug is pointing, close to that small dot, which is a small galaxy that's called M32 or NGC 221, as you can see. NGC stands for New Galaxy Catalog or New General Catalog, I think. It's not new anymore. And M32 is the 32nd object in the Messier catalog. Charles Messier was someone who documented this. But coming back to our sun is one of a few 100 billion stars. 100 billion means 11 zeros. That's how many stars make up the Milky Way galaxy. And on a clear night, from a place away from city lights, you can see a band of light across the sky. That's our view of the Milky Way. It's the collection of stars is in the shape of a disk or a frisbee. We are part of that disk. So when we look at our own Milky Way, it looks like a band of light in the sky. How many of you have seen this from either from your home or from when you go to a dark site? Has anyone seen the Milky Way? Feel free to answer in the chat or feel free to unmute and answer.
I've only ever seen it when observing in person.
I've seen it from Hawaii. I had seen it before in the Himalayan foothills. It's very dark over there.
Used to be able to see it from my uncle's house in Tahunga before the light pollution got too bad.
We can see it from Mount Hamilton when we go up to Lake Observatory. I could certainly see it from Pinnacles National Forest. So when we go away from city lights, you can see it. So Andromeda, the picture that Rob took that Doug was just displaying, you can see it's shaped like a frisbee. It's shaped like a disk. That is the nearest galaxy that's bigger than our own. Okay, so it's not the absolute nearest galaxy to us. There are some galaxies that are small galaxies that are closer to us, but this is the nearest galaxy that's actually bigger than our own galaxy. And you can see that it's shaped like a disk, it's shaped like a frisbee, it's spinning. And we are trying to figure out how fast things are spinning, how uniformly things are spinning. By uniformly, I mean, are all stars orbiting at the same speed? Those are the sorts of things that are important for understanding the history and past and future of the Andromeda galaxy. I'm conscious that in less than 4 minutes, in 3 and a bit, we have to change masks.
So yeah, and each of these aluminum plates that we use that are called masks, they can observe up to 200 stars at a time and get their velocities, get an estimate of how fast they're moving either toward us or away from us. And if we observe enough masks, then we can get a good sense of how the stars are moving across the entire galaxy.
How long have you been tracking the Andromeda galaxy for?
A long time. I think Raja has been focused on Andromeda since at least the early 2000s. I mean, probably before that.
Yeah, my first observations of Andromeda were not of this kind, where we are taking spectra of stars. I first started taking images of Andromeda over 30 years ago, 35 years ago, would have been in early 90s, like 1991. Maybe it wasn't until 91 or 92 that I started. So that's, 1991 is over 30 years ago. I first started taking spectra of Andromeda in, I'm going to say 1996, with one of my PhD students, David Reitzel, who is the reason for my connection with Rob, because he works at an observatory in LA now. But recently it was the anniversary of my first night on the Keck telescope. That was not so long ago. It was in September, I think, earlier in September, 16th, I think.
How
But
have you
yeah, sorry, Sophie, go ahead.
how have you seen it changed over the years?
I mean, the galaxy hasn't changed at all, right?
For the
Because
picture.
it doesn't change very much on human time scales. But what has happened is our understanding has changed, because as we've, even in the course of 30 years, we have better instruments to measure the light of Andromeda. When this particular instrument we're using tonight, it was first used in 2002, 22 years ago. And when we were first using it, the instrument had just been built and it wasn't working as well as it is now. Some of the software components, some of the hardware components have been refined since then. So, Doug mentioned that we can measure up to 200 stars at once. That certainly wasn't possible early on. We were measuring many fewer at a time. And the quality of the data wasn't as good because when you take this is generally true in astronomy, right? For a telescope that's on the ground, when you try to study the light of some distant object, you have to disentangle the effects of the instrument and of the Earth's atmosphere, which glows. It glows, it absorbs light. And those things, the removal of instrumental signatures and atmospheric signatures requires very careful characterization of the instrument. And that has evolved a lot since the instrument was first used.
Wow. That's like a lot of factors.
A lot of factors, and then Doug and I, in the course of these 30 years, I would say in the last third of those 30 years, over the last 10 years, I was looking at a bunch of spectra and I discovered something in the something in the spectrum that was unusual. That has led to a couple of papers that Doug and I have recently submitted to the journal. So there's been leaps and bounds in our understanding of the galaxy.
Do you track other galaxies in like a similar way?
Yes, some others, not all. Andromeda keeps us busy, but there's another galaxy called Triangulum that we study also. So I'm going to step away from this and go to the other Zoom call for a moment to change masks.
Okay.
Okay, yeah, I just did the course alignment. I think it looks good. I'm going to do the fine alignment as well now, if that sounds good to you.
This
Sorry, you changed Zoom links and I'm still here, so I don't have the sharing on this one.
No, that's fine. That's fine. I can see it in this. I'm on both Zooms, so it's okay.
Surprised you're not echoing because you are unmuted on both Zooms as well.
I've got my headset on one. That's fine.
Mhm. So now what we're doing is we just observed the star, the aluminum plate, and we're centering it on the right part of the sky, and we're using really bright stars to do that. Now we're using bright stars on each side of the aluminum plate to rotate and align the plate perfectly so that every little slit that we milled into the plate lines up with the star that we want to observe in the sky perfectly. And so this is kind of an iterative process. We ask the software to match, and then they say that we need to move the mask a little bit, maybe rotate it a little bit. And then we have to do that and then take another image and keep doing this until it basically says that you're good to go. So for example, this doesn't.
Not look. So let's do another course align.
Should I select a different guide star? Or should I
No.
just grab guide or image?
Let's grab a guider image. Yeah, I'm not happy with the.
Okay. They look on top of each other to me.
Yeah, I don't know why the final line didn't work.
Try again.
Okay. We may have to go to imaging course align. Because it looks like it's too far off. There's nothing in any of the boxes.
Also getting close to the time where Andromeda will set. Do you think that's having an effect?
Yeah, it's getting to be higher MS, but I don't think we would have seen peaks inside I mean, the seeing hasn't gotten that bad. We're also working in the red, so I'm not, I
I
think
mean,
we
I
should go,
see the stars in the image here, the residuals. But yeah, it's not great.
yeah,
Should I increase the exposure time?
I don't think so. I think we should just go to imaging Cosaline. I'm a
Okay.
little worried that without that, we're not going to see
So I
it.
need to select this mask, which is this one, and then I
Right.
need to click acquire. Is that
I
right?
think so. I think so.
Oh dear.
Let's see. Let's go to control 0. It should be removing yep, good. It's removing, it should be removing the slit mask. It should say none soon in control 0. Yep, good. So it should take an image. We should be able to zoom in. We could reach out to Michael for this one because I think this is running into the same issues that we ran into for one of the masks. Sophie, are you on from 2 devices or is that a link that someone else is using?
Oh yeah, one of the girls from Afghanistan said that she couldn't answer the questions and sign up.
No
Um,
problem. What she can do is she can easily go in there and change the name in Zoom. Right now she's showing up as Sophie Lee, but she can easily go in there and rename herself. I can rename her if you tell me, or if you want to tell me what her name is.
okay, I think it's
So
Hanya.
I just taken 2 images, is that right? Yeah.
I think so. Anya,
Yeah,
and last
H-A,
name?
um,
Jnia?
yeah, Hania. I'm not sure about her last name.
No problem. I've just changed it.
Okay, thanks.
Hello.
Hi, Hanya.
Hi, how are you?
Good, we can hear you.
Now can you hear me?
Yeah, we can hear you.
Okay. My name is Hanya and my last name is Iskandari.
So you can, if you want, if you click on next to your name, there should be 3 dots. If you click on that, you can rename.
Okay.
Doug, what is going on in control 2 now?
So it should be making the
Should I
image
write
now.
my-
Oh, very good. Okay.
So I click one of
should I write
these,
my-
Yeah.
and then I think it automatically did something. I don't remember what the next step was after this.
Me neither. Um,
Hanya Iskandari.
I think it was move, but I could be
think-
wrong.
we should we should get Michael on.
Okay.
I haven't
Tony, is
used
it
this in.
possible to call Michael? Thank you. We're
Mask
just
alignment.
having the same thing where we need to do image course alignment. I think it was move, but I'm not sure.
He did something where he zoomed in a lot and you could see that that the box and the star that was intended for that box were quite far apart.
Hmm. Should I think I'm gonna go back to the other Zoom link if that's okay.
Yeah, no problem. I can hear you on both anyway.
Sorry, folks. It's just that this is time critical a little bit. So
Yeah, absolutely. You should. I missed what Tony said. Okay. Yeah, sorry, Michael. Yeah, when we did the regular guide course align and went to final line, there were no peaks in any of the boxes. So we tried guide course align a couple of times to no avail. So we thought imaging course align would be the best path forward. Now I'm getting the audio from the instrument. I wasn't before. Oh, much better. Thank you. Yeah. So Sophie, Rob, and the OMID students, we think we've just been able to troubleshoot the problem. So we are going to be continuing in just a couple of minutes.
Okay, sounds good. There are a couple girls from Afghanistan who lost connection, and I'm texting with them, and I think they're trying to log back on.
Okay. I think Masuma Rezale is rejoining from what I can see.
Yeah, she said she's joining with her sister.
Oh,
So-
excellent.
Yeah, I think because of their weak internet, it's hard to show their cameras.
Mm-hmm. So we should just do 311s or 312s. Let's do 311s. Perfect. This is aligned. Right. Let's do 660. GuhaThakurta. Yep, we're good. That's good. They all went well. Right. Yeah, most. Is the so now that this is going, I'm just going to go back to the other one. Yes, that I know how to do. That's usually on the FACSAM and Guida. So on tel status. So let me see, Zara, Masuma. There are two Masumas, two different Masumas, and Hania. Is the connection, is your internet connection better at the community center than it is at home?
Yeah, there's some girls are like they go to the community center, and then some girls are not from the community center.
I see.
I think many of the ones who originally go there were not able to make it.
Okay.
But yeah, because last time I talked to them was in June, and I
Okay.
think back then this would be like the best time.
Okay.
But I would have to ask her for new times.
No problem. No problem. If there are any questions that anyone wants to type into the chat, would be, or you can ask by unmuting. I want to make sure that everyone's able to unmute. I'm going to do that right now. But if anyone wants to ask a question, please feel free. Oops, sorry. I didn't mean to mute Anya.
Yeah, Zara, Masuma, Hanya, how much do you guys know about the Andromeda galaxy?
Well, May, it's the first time I've ever heard about it because I've only known about Milky Way galaxy, and the photo I've seen, like I can say that was so amazing.
Yeah, Masuma, the Andromeda galaxy is like the Milky Way, very similar, but we are inside the Milky Way, but we're outside the Andromeda galaxy. So that's why we have in a way, we have a much clearer view of Andromeda because we are inside the Milky Way. And the Milky Way stars are closer to us, but because we're inside it, we have a sort of distorted or unusual view of it. In this sense, so Doug has joined. Doug, I'm going to make you co-host again so you can share. Yeah, so it's a real trade-off, right? I mean, I'll give you an analogy to try and explain this. If you imagine that we have a clear view of our own house, right? Because we live inside the house. So let's say if I'm inside my house, I have a clear view of the room I'm in, but I can't see the other rooms. And I don't know what my house looks like from the outside. But if I look out of my window and I look at my nearest neighbor's house, I can now see what a house looks like from the outside. I can get a better sense of the whole house. I can't see as many details of the house, but I get a sense of the big picture, what the shape of the house is, what the height of the roof is, those kinds of things. So that's not a perfect analogy for the situation between the Milky Way and Andromeda. Andromeda is like our neighbor's house. The Milky Way is like our own house. that we are inside.
Oh, so you mean we don't have an actual photo of the Milky Way, but we only have some guesses based on the pictures we have seen and captured from other I'm sorry, galaxies?
Galaxies. So we have pictures of the Milky Way, but they are pictures taken from the inside. I can show you a picture of the Milky Way. Actually, I'm going to put let me see if I can. Let me. Is it okay if I share my screen for a moment, Doug?
Yeah, go ahead.
Okay, so I'm going to share my screen. This is a picture that one of our colleagues here at Santa Cruz took not so long ago. I used it in one of my talks very recently. I used it earlier this week. So this is a picture of the Milky Way, for example. This picture was taken by one of the researchers at Santa Cruz. You can see the picture. It looks like a galaxy, but we are inside the galaxy, actually.
Oh, it's like so amazing. And the previous question you asked, like, have you ever seen one? And I thought maybe for seeing it, we all need a telescope. But in Kabul, we don't have a clear weather most of the time. So in my summer vacation, when I went to the countryside, I was like, I could look at these traces in the sky, in these patterns, and I didn't have an idea what it was. But when I look at this, they were just the same, but there were no any
I bet
colors.
you were seeing the Milky. Yes, you don't see the colors because it's very faint, but this is because this is a photograph. It's a digital photograph. The colors are a little easier to see. But if I show you, I'm going to skip through some of these slides, but I have a picture of the Milky Way later that I'm going to get to. Sorry, not the Milky Way. This is the Andromeda galaxy. This one right here. So this is also shaped like a frisbee, but it's not perfectly seen along its edge, whereas we are seeing the Milky Way perfectly along its edge from the inside. So if this were the Milky Way, we are not at the center, but we are somewhere there within the disk looking. And when we look towards the center, it looks like that first image you saw. It looks like, where is it? It's like this.
It's so interesting.
Let me see if I can. These are all my slides. I was giving this talk. Doug, the second half of this talk is about, you'll recognize, similar to what I presented in the workshop in Tokyo. In fact, identical. I didn't change anything for the second half.
And the colors, seeing the colors is just it's the picture has to be taken from a telescope that the colors are visible, or is just some editing done on the photo?
The colors are visible to the human eye, but it's very faint. That's why it's difficult for us to see the colors. So this image that you're seeing here is just a high contrast version of what the eye sees. Just high contrast, meaning the galaxy is more clear and bright against the dark sky, but the colors have not been particularly enhanced in this one.
Oh yeah, now I got it.
Yeah, I think of this as sort of natural color. So parts of the galaxy are blue. This part that I'm highlighting in the outer regions, these outer regions are sort of blue. The inner regions are not so blue. They're more yellowish, white, or even brown or red in certain parts. Like these lanes are red.
Also, when we're looking at the Andromeda galaxy with the naked eye, it's usually very dim, and we're using the rods rather than the cones, and the rods are black and white. So
Oh, I see. I see. These are the different cells in the retina. It's a great point, Rob. I hadn't thought of it that way. And the change you're seeing in the image, I've now superposed an image of the two telescopes on Maunakea. One of those two telescopes is what we're using tonight. These are spectra from a paper that Doug and I have been working on. Anyway, this is a paper that Doug has recently completed and submitted to the journal. In these plots that you're seeing, every dot is a star that for which we have a spectrum, and then the y-axis is a measure of how bright the star is, and the x-axis is a measure of the temperature of the star, but it's an inverted axis. The temperatures, the higher temperature stars are on the left, and the lower temperature stars are on the right. So these are different kinds of measurements that people can make. The x-axis isn't exactly temperature, but it's a proxy for temperature. It's a measure of the color of the star. So blue stars are on the left, blue meaning stars that would look blue to our eye, not the blue dots or the red dots here, but stars that would look red to the eye are shown on the right of these three diagrams. In all cases, the stars that would look red to the eye are shown on the right. Stars that would look blue to the naked eye are shown on the left part of the diagram. So the x-axis is a numerical measure, different numerical measures that astronomers use to quantify the color of an object.
What was your paper about?
It's about this class of stars called weak CN stars, and it's a discovery of something that people hadn't noticed in stars before. I'll go back and I'll show you what I mean. If you see the three stars on the left, each of these is energy as a function of the wavelength of light, or what kind of the nature of light. And these three spectra show these very strong W's. You see this shape that looks like a W?
Yeah.
This was well known. These sorts of stars were well known. But if you look at the stars on the three stars on the right, there's a very faint hint of a W, very weak hint of a W. You could sort of make out that there is a W there, but it's much less prominent than this one, than any of the three on the left. So this W on the right is so weak that people hadn't even noticed they exist. But there's a whole class of stars that have this very weak W, along with a whole rich set of other spectral features that people, they had noticed the rich set of other spectral features, but they had failed to notice this W as far as we can tell.
What kind of implications does that have?
It's related to this molecule that's a combination of carbon and nitrogen. It's called cyanogen. That's what produces this W-shaped feature. And I was just saying to Doug earlier today that C and N occur in pairs. So you have two of these CNs connected, the two Cs are connected by a bond. Because carbon can form 3 bonds, nitrogen can form 3 bonds. So when you form CN, the carbon has an extra bond it can form. So it bonds with another CN's C. So you get C2 and N2 together, almost like hydrogen peroxide is H2O2. The oxygen forms one bond with hydrogen, the other oxygen forms another bond with hydrogen, and then they have a second bond free that they bond with, the 2 oxygen atoms bond to each other. So you get hydrogen peroxide that way, which is whose formula is H2O2. This is like a C2N2.
Oh, so that
Roger, just want to let you know that the first exposure finished.
Oh, okay. Let me stop sharing. How
looks
does it
like
look if you pan around?
it's very faint.
Very faint, huh?
Because it's about half of our usual exposure time.
Yeah, it's half of our. Do you want to change the, let me see, try changing the upper level to 1100 for the cut levels.
Yeah, I
Something
can
there.
see it.
You know, since we have the exposure time, I figured we should change the.
So yeah, so you're the expert when it comes to deciding. 'Cause I don't understand the procedure for understanding when to stop when it comes to the telescope limits.
You know, so for that, if you go to FACSUM, which is on the tel status window.
This one?
So if you look at the elevation marker, it's at 40.38. It's in the right column, upper
Yeah,
part
I
of the
see
right.
it.
Okay. So when that goes to 36.8 is when what we'll see at that point is stars will start to streak in this magic image on the left. At that point, we'll go across to control 0 and abort the exposure. Sorry, stop the exposure and read out what we have so far. Now it also gives a time to limit. So we could shorten the third exposure to fit into that. But the
Yeah.
advantage of doing it the way of waiting for it to stop and actually trail, then we maximize what we can do with the telescope. It's not like we're damaging the telescope. There's a software thing that prevents the telescope from moving at some point. And at that point, we stop the exposure. So this is the second of the three that it's doing, right?
Yeah.
Okay.
And then after this, we'll have 1 more hour. Is that right?
Roughly that. Little more than that, depending on, we have somewhat bright stars in the Wolf-Rayet stars that Rohit has given us. They're somewhat bright. But the other thing is M33 will hit that limit at some point. So I don't think we can get the full, what will happen is, let's see, M33 is 1 hour 33 and M31 is 0:41. So the difference is something like, it's not quite a full hour. It's 50 minutes
Okay.
before M33 hits the Nesmith deck. So for the Wolf-Rayet stars, I figured we'd do 2 5-minute exposures because they're super bright.
Yeah. Do you know which one you would like to do first?
Yeah, I have a list, and their magnitudes are in that list as well. I mean, I don't know if the magnitudes are.
Yeah, the magnitudes are not here.
I have them in the list. I think they get, they don't get picked up by the. Oh, the mag is showing up as 0. Oh, I put imag equals. That's why I should have put mag equals. But let me see. I can find it very easily. Wow, we just had an earthquake apparently.
In Northern California?
Yeah,
Did you feel it?
I didn't.
Did Masuma have a question?
Yeah, please go ahead.
Masuma Rezai.
Hello, I hope all of you are doing well. In reality, you talk about the galaxies and stars a lot. I wonder if you give us a little information, or have you ever took any picture of black holes, and is the white holes are real or no? Because I heard about them, but I didn't see any. I couldn't find any documentary that explained about the white holes. But I
Okay.
know that black holes reality, and there is some evidence as well.
Yes, so black holes are well studied and a lot of people study them. I have studied them also. I've written some papers about them. White holes are much more speculative. They're not, there's no clear evidence for them. But for black holes, there is very clear evidence based on our current understanding.
Yeah, so for instance, we've measured stars that are orbiting around something that we can't observe, and that invisible thing behaves just like a black hole in every way that math predicts. And we've also observed the gravitational waves of black holes being formed, and it also follows the mathematical predictions perfectly, basically. So there's a lot of observational evidence for black holes, but yeah, white holes are fully theoretical.
And Doug, I was thinking about the Event Horizon Telescope where people predicted
Yeah,
that light should.
we've literally imaged a black hole also. Yeah.
The bending of light by a black hole and what that should look like, even that has been imaged. That was right before the pandemic that happened.
Masuma, where have you heard about white holes?
In reality, because I am so interested about these stars, I always try to search about them. And one day, I think it was in YouTube or maybe some text, I read about it, and then I tried a lot. Unfortunately, I couldn't find more information about it.
Yeah. That makes sense that you couldn't find more information because they're not, no one even knows, people don't even know if they're real white holes. They can exist mathematically, has been shown, but whether they do exist is different. Hasn't been shown. Hasn't been proved yet.
Okay, thank you so much.
Sure, sure. Masuma, which are Masuma, Zara, both Masumas, Hania and Zara, are you all based in Kabul in Afghanistan?
I am.
Okay, both
Yes.
Masumas, yeah. And okay.
Yes, I
And Hania, you too? Okay. Same for Zara? I grew up I grew up in India, which is 2 countries over from Afghanistan. To the east of Afghanistan is Pakistan, and then to the east of Pakistan is India. I grew up in a part of India that is near in the eastern part of India, so not close to the Afghanistan side, but close to the close to Bangladesh, actually, close to where Bangladesh is. Are you big fans of the Afghan cricket team? What's, they did very well in the Cricket World Cup. I'm trying to remember the name of the famous Rashid Khan.
Actually, no, I'm not a fan of cricket and I don't have much information about that.
Ah, okay. I'm a big fan of cricket and been following the Afghan cricket team.
Second exposure is about to finish.
About to finish, yeah.
I'm also keeping an eye on the angle that you mentioned. You said 36?
36.8, yeah.
What do you guys mean when you say exposures?
So it keeps the shutter open, it collects light, and then it closes the shutter and reads out the silicon device and records that as a digital file. And then after it's done that, it reopens the shutter and starts collecting light again.
Where is
So
the telescope based?
it's in Hawaii. It's on the Big Island of Hawaii on Maunakea, which is an extinct volcano.
Jamaica,
Sorry. Sorry, what was that, Sophie?
Oh, is Jamaica running that telescope?
No, Jamaica isn't. Jamaica is based in Hawaii, but not on Mauna Kea. She's in Hilo. Jamaica, the telescope is being operated by an observatory called Keck Observatory. This particular telescope we're using tonight. And Jamaica used to work for a different company, a different organization, different observatory, whose telescope was also on Mauna Kea. But in January of 2023, so January of last year, about a year and a half ago, she left that observatory to join UC Santa Cruz to work with us on Shadow the Scientist.
It's really cool. How long has Shadow the Scientist been around?
Officially, as a, well, I can give you three different answers, Sophie. When we first started it, we had a different name for it. And that was in November. The exact date is early November, November 6th, I think, of 2020. So that's coming up on 4 years. But we weren't calling it Shadow the Scientist then. We were calling it Starry Night or something like that, Starry Night, as a tribute to Vincent van Gogh's painting. Then it must have been at least 6 months later that we said, let's change the name from Starry Night to something that depicts what the event actually is. So we changed it to Shadow the Scientist. So that would have been in the summer, I think, of 2021. And then we got funded and we were able to hire, Jamaica was hired in early 2023. The funding came through on August 1st of 22.
Is that from the university?
No, it's actually from a private foundation. It was money given by the private foundation to our university so that we could hire people to at least hire one person, Jamaica, and part-time compensation provided to other experts as they were helped us launch this program. So that was a 3-year grant, started on August 1st, 2022. So we're just started the 3rd year of the grant.
Wow.
But after the grant ends, we intend to continue the Shadow the Scientist program. We intend to ask the same foundation and other foundations for continued support.
Yeah, it's great.
So, Raja, did you get a sense of which of the Wolf-Rayet stars you want to observe?
Yeah, we want to start with, I'll tell you in a second.
So we have 4 minutes until the limit, I think. That's what it's saying here.
Yeah, that indication is conservative, so we'll be able to go past that without a problem. But let me just see. Give me a second. The most promising one is the second one, Wolf-Rayet 62. That's the brightest of the ones that I see here. I think we should start with that.
Yeah.
So we could either go with the brightest one, or I propose yeah, sure, let's go with the brightest one.
Okay. So then when it hits the time limit, I should click abort. Is that right?
Not, I would say let's wait. On this screen, we'll know exactly when to hit abort. As soon as it starts, the guider stops and it starts. As soon as guiding stops, we'll switch to control 0 and hit stop. For a moment, let's go to guiding. Let's go to control 0. I'll show you which button to hit.
This one, right?
Yeah, we would stop and then we would save. When we hit stop, what happens is it gives you the option of either aborting or saving. We'll save.
Okay.
And what we'll do at that point is record how many minutes have elapsed. So it's looking like it's telling us it's 2 more minutes, but we'll see that it allows us to go a little bit more than that before it hits 36.8. So if we wanted to, it'll be about, it won't be more than, it certainly won't be another 5 minutes. So if we wanted to, we could cut the exposure time. We don't need to right now, because it'll, when we abort, it'll tell us what the, and we should note that in our observing log.
Okay. So I hope that's all good with you, Tony.
Tony, is that okay with you? We are just going to wait till the guiding stops. It's going to be parallactic. And we are going to be doing short exposures, just 5 minutes. Or 2 times 5 minutes, 10 minutes at most. Oh, and Doug, one of the things we'll want to do is when this one starts reading out, or when we abort, oh, Rohit has joined. Wonderful. So when this one starts reading out, we'll want to switch to LVM slits. And
Okay.
Hi, Rohit. Rohit, we're just getting ready to go to, see, it says it's hit the limit, it's 0, but you can see that guiding is continuing and elevation is continuing to drop. I'm pretty sure it's 36.8 where guiding actually stops. And Doug, how are we doing on the exposure time? A little over half, 400 and something, okay. I think we'll probably get to 500 seconds. So most of the way to 11 minutes. Tony, please give us a holler when guiding stops. We are keeping an eye out also, but please give us a holler. And Rohit, as soon as this one stops, we'll go to Wolf-Rayet 62, which is the brightest of the lot. And we'll do 2 5-minute exposures. Doug, say that again, please. It's at 36 point. Yep, I'm watching it, 9.2. What will happen is it'll become very obvious on magic. Stars will start to streak across. That's when we stop. Yep. I think if I'm not mistaken, it might even be 36.78 or something like that. It's the exact value I don't remember, but it's close to 36.8. Yep. Okay, and you can see that the total exposure time was, I didn't note what it was. Yeah, change that to LVMs, let's see. And we'll want to put this on the second narrowest, which is the 0.8 arc second, 0.8 or 0.9, whichever that is. Oh, no, Tony will have to do that. Not sure. Yeah, but Tony's going to put it on parallactic. There's an automatic way of doing that. Yeah, we are ready to slew there now. Let's see, I'm looking at that, Doug. We want to change to 600 ZD. And that should make it, yeah, we want to switch the filter. You can start that now. Yeah, GG455. Yeah, please, that one. And we shouldn't have to do anything to the wavelength. It should show up as 7200 without a problem. And then we want to change the object name because there won't be any alignment being done here. You can just change that to to M33. What is the name? WR62. Perfect. Yeah, perfect. Thank you. 300. Perfect. And then we'll do a WFFCS GuhaThakurta when the time comes. We have to wait for Tony to put the star on. There's a long slew, and then he'll have to put the star on the slit. Yes, this is going to be LVMs. Let's see. The second narrowest one, which is the, is that 0.9, I think? 0.9 arc seconds wide. 0.8, that's perfect. That's the one we want. The grating is still adjusting. Oh, it's highlighted. Oh, I see. Oh, I see. I see what you mean. Can we cut the contrast a little bit? Because there are two bright stars inside that. Huh. I see what you mean. The bright stars are embedded in that nebulosity. Rohit, I'm looking at the image. How can we? Can we cut the exposure time on the guide up by any chance? Okay, what is it now? Is it 10? Did it update already? Can't, it looks like a blob over there. I can't, I mean, I can see Rohit has made finding charts and it looks like the finder chart. But yeah, I think so. Rohit, north is up and east is left in your images, right?
Yeah, the axes are reversed.
What do you mean?
Yeah, north should be up. It's
Yeah, 2, please. Rohit, tell me the orientation of your guide images. Oh, deck is up. Yeah, north-south is deck is up. I can see that now from the cartoons.
yeah.
So these are these very bright stars that are near the end of their lives that we are trying to take spectra of. The grating thing has gone to unknown, I see. Oh, because it's still trying to line up. I wonder if we have to change the rotated angle to -3 to change gratings. No, I'm wondering, but I think the grating is, it still hasn't gotten there. We're trying to change the grating to 600 ZD and it hasn't completed the change yet. Try it again. Yeah, select that. The change of grating is always a sensitive thing. And I know that sometimes we have to rotate the instrument to -30 to get the grating change to work, because the gravity vector is then favorable for a grating switch. So we may have to do that before switching it back to parallactic and reacquiring. Let's give it a little bit. It's not doing it. It's a good Michael question. Tony, is it okay if we put the if we change the instrument angle to -30 and then rotate angle? Yes. I think we need to do that just to get the grating unstuck. We may need Michael's help for this because we haven't The grating is stuck. Okay. And please let us know when it's gets to that rotation angle. We'll try the grate. Oh, you can. Okay. So minus 30 is the same as minus 390. Dropped at minus 349. It says rotate angle is minus 349. This is what I'm not sure of. Maybe we should ask Michael. Okay, please. Thank you. Doug, you could try hitting apply to see if it does that. At least the progress bar is going again. But it stopped at 26. I can't think of what else we can do to get the grating unstuck. Oh, got that. Okay, fantastic. So we're good. We want the parallactic angle again on the, now we can, it is moving, okay. So let's go to, yeah, as soon as Tony gives us the go-ahead, we can start. We can look at, if you want, we can look at tail status to see how the rotation is changing things. Yeah, you can see it's rotating. But it should bring that Wolf-Rayet star back to the second slit from the right, the second narrowest one. And Doug, I don't know if you can see, but the time to limit, it says is 39 minutes. So that's how much time we have left on M33. Thank you, Tony. Tony, is there sorry, Tony, is there a bright star in that clump that we can put on the slit? Or is that not visible? You know, the brightest. Got it. Okay. Yeah, let's run it. The exposure has started. Fantastic. I'm still trying to square the image that we see on Magic with Rohit's guider image. Wait, this is star 62, right? I was looking at the wrong one then. I was looking at the wrong image. We've got the correct star on, I believe. The can I share my screen for a second, please? Actually, you know, Doug, I'm going to forward you a message, if that's okay. I've just forwarded you the find the charts, Doug. Through email. And the second, I think the second object in the list, I believe, is the one we're on, WR62, which is the second of the finder charts.
About this. Looks like your FDF isn't correcting. I think what's going on is it didn't pick up the
Wavelength.
what wavelength?
We want 7200. I see. So it started the exposure even though FCS didn't match. It's almost, I mean, let's see. For the second exposure, we can make sure it tracks. So let's do something. Yeah, Control C out of that window. The WFFCS window. You're not sharing your screen anymore. I'm exactly. We'll just tweak the wavelength a little bit.
So just wait until
We should get a good exposure anyway. It should be fine. Doug, when you have a moment, please share your screen so I can see the spectrum of this thing. Thank you. Oh, so it's reading out now. Excellent. Okay. So it,
it's like a so -30 is where we usually plant with grading, like in the afternoon. So if there are issues, then we do go to -30, and then we select the grading at that point, and then go. Yeah. Okay.
What does the spectrum look like of this object? Let's take a quick look. Or should we start the next exposure? So it'll be a little bit over to the left. There we go. Yeah, you're right. Let's start the next one. Just go I. Yeah, just go I. And it should be tracking at this point, so. Yeah, there we go. It started.
Yeah, and the fact that it didn't show any big correction or anything, it was a short exposure, means that the first one was probably good.
Yeah.
So it probably started tracking and then was offloading. Yeah, it's either offloading some to the grading or just for whatever reason, you know, had like a rounding issue in software where instead of 7200 it was 7199.99 or something.
Mm-hmm.
Good tracking and then
Got it.
but I'll make a note of that.
We've got 2 stars in the spectrum, and I think I know which 2 stars they are. What is the PA that we are using right now? Negative? Did you say? Oh, 222. That's the sky PA, is it? Okay. Okay, so that's the physical rotated angle. Sky PA is minus. Okay, so yeah, in fact, we can see the compass rose on Magic. East is pretty much left, north is pretty much up. And so if I go to Rohit's image, what it's doing is it's picking up this bright star that is a little bit, a little bit below it and to far left. It's picking up big. You can see we're getting 2 spectra there. If you go to control 1, we got 2 spectra. If you zoom in a little bit, Doug, I think we'd be able to see the emission lines even. Please change the height to 1500. Very good. Okay, now, so there's a way to march along the slit by using the window to the right, the main window. Yeah, so that's the A band. We can see the A band. And keep going. That's the chip gap. That's 7200. There's a P Cygni profile. Wow. That's H alpha and 2 sulfur 2. So those very bright lines we saw earlier that you can sort of see on the, yeah, these lines right at the, what is this that we, oh, this is O3 H beta. This is H beta and O3. Let's go to the one immediately below. Let me double check. Yes, 67, please. So as soon as this one finishes, if you highlight 67, we'll ask Tony to move to that. And when it's done, he'll move to that, and then we'll do go I2. No, we don't need to go to 0. We just, that's only for if you want to use the Exactly. Exactly. Once this readout is finished. Because the Go Zero is only used for mask alignment. For long slit, we never use it. Doug, after we start this one, I'll share my screen for a moment because I have the Finder charts up and I'm getting a sense of what we're seeing. Yes. There should be two bright points, and it's the one that's furthest south that we want to hit. Oh, 067, yes, please. And I want to see the guider image one more time, please, after you're done that. Yes, yes, absolutely. And it should start because it's tracking. I just put it on a little while back, but don't need it now. Thanks. The guider image looks very similar to the way it did before, so I'm a little worried about that. It's definitely on 67 because it says that on the FACSUM. Yeah. What was that, Doug? Sorry. No, 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 of course not. We'd probably get maybe one or two more at most. No, No. I'm a little confused by the guider image because it looks very similar to the previous one, whereas the two finder charts look very different for the two. So I see. Actually, hold that. I want to see Rohit's image. It's so messy and complicated. It's so hard to see what's going on. Oh, I think I know which one we want. Okay. We go back to the image for a second, please. Sorry. And if you go to the guider image again, the one that was DEIMOS guider. Can we go back and forth between those two for a second? I see. I'm having a hard time squaring away what I'm seeing here. For the other view, DEIMOS guider view, can you up the contrast again, please? There's a slider there. That's better. Okay. Much better. Okay. It should read out fine and go to the next exposure. That's no problem. Rohit, you see how complicated these fields are. It's very difficult to identify which star is which. We've again got two stars. Yeah. Well, actually, no. Let's not do the next one down because that's a bit crowded. We can do the very first one on the list. Rohit, you've left off the ones that we already have spectra for, right? I assume. Right, Rohit?
I think so. Let me confirm.
165 is a good one. But the very first one is a good one also. So let's go to the very first one. And actually the one after this is not bad. It's not bad. Where was that, Doug? That's good. Yeah, let's do the first one after this. I wish we could capture the slit images of the guider. Is there a way to save them, Tony or Michael? This will at least tell us where the guider was pointed after the fact. Okay, and this one is associated with the target 467. I wish we had saved the previous one also. This is now doing the first exposure or second exposure. Okay. Second exposure, and this is the second Wolf-Rayet target, right? Okay. Yeah, I'm really concerned because I'm not seeing a correspondence between the image, between Rohit's finder chart and this image that we're seeing. Okay. Rohit, I'm looking at the finder charts and WR160. We should avoid because there are two stars that are of equal brightness very close together. Okay. And that
60 is not in the list, I believe.
so this is 055 we are going to. Okay. But we are slewing there, is it? Okay. No, this is why I'm so confused. I'm not seeing on these images, I'm not, I wish I could If I could, how can I show my screen without, I have to share to show my screen. Yeah. Let's save an image again of the guider. Yeah. Yeah. Let's save this guider image, please, because at least after the fact, we can try to reconstruct which stars we got spectra of. We should have, yeah, these were bonuses anyway. I wish we had done that for the very first object we tried, but because, okay, okay. Because one thing we can do after the fact is, you see this guider image that we're seeing in the upper frame, we can put down slits of comparable length to the 5 LVM slits on an HST image and see if the two line up, right? When we, because when we see the guider images, when we see the finder charts, we should be able to make sense of the finder charts, the HST based finder charts and these images later. In hindsight, the better way to do this is, these stars are in very crowded regions. So it's better to find an isolated star that's nearby. We actually picked the most isolated. Rohit picked some of the more isolated Wolf-Rayet stars. But to pick one really isolated one, and let's say that's 100 arc seconds away or in X and 50 in Y, find that, center that on the slit, and then apply a blind offset to get to the Wolf-Rayet star. That's the way to do these in the future. The spectra have very good signal to noise, so that's good. And we'll be able to tell from the spectrum afterwards whether this has characteristics of the Wolf-Rayet star. do an end of night shutdown. That's what we'll do at the end. After this one is done. So this is in the background light blue part of the menu. So don't do it just yet, but it'll be under DEIMOS control menu. If you click on that, you'll see. You'll see under DEIMOS control menu, there's an end of night shutdown. Thanks, Rob.
See you next time.
See you next time.
I was wondering what time you'll be staying until.
We'll be wrapping up very soon, Sophie.
Okay.
We are on the very last target of the night, so it's another minute or so of exposure time on this one. Less than that even. When this 253, 54, when it hits 300, that'll be the last of our exposures.
Okay. Did you do the same thing in your last session yesterday?
You know, it wasn't, we didn't do these single object, one at a time thing. We were only observing master in the previous session. You guys got to see a bit of both. We finished up some mass and then we went to individual stars after that.
Thank you.
And the individual stars were in a different galaxy called Triangulum, smaller than the Milky Way.
Oh, is that where these are being photographed from?
Yeah, that's where these spectra are. It's a little further away than Andromeda. The galaxy is smaller than Andromeda. So now we should be able to do the end of night shutdown as soon as this readout finishes. Oh, Doug, let's do. So remove the FCS window. Move the FCS window aside. Sorry, no. Where is it? Move it to the right again, please. Sorry, Doug. Yeah, move the, sorry, FCS back all the way to the right. And Doug, the other thing you want to do is save your observing log. You can overwrite the existing file. It was in the right, yes, that one. You know, before you do that, one comment we should write down is, let's see, where are the last few things? There was one where the exposure was truncated. And it was truncated by the Naismith deck. How come those didn't get captured? If you refresh, it should, you see where this says refresh Firefox button? There's a button that says refresh Firefox. No, we don't want that, sorry. That one. And now if you scroll down, we should see a few new exposures that. Which one got truncated? Let's see. One of them we had to truncate, right? That's the one, 532. You can just say truncated due to Naismith deck. Naismith deck, NAS, MY, and ASMYTH. Naismith deck. Yeah. What is the one with the key error? I wonder what that is. Sorry, couldn't understand. Oh, I see. When the grating got stuck? Got it. I would save this, yes. Or it's made a copy with a parentheses 1, which is fine. It's okay, as long as we download it. So what I'll have to do, there's a couple of ways to do this. We should download this to Pemla. Or upload these. Download these to Pemla. I think you can do an end of night shutdown. That won't end the VNC, but you can do an end of night shutdown. So in any of these gray things, click DEIMOS control menu. And end of night shutdown is the second last thing. And hit yes in that little window. Are you sure you want to? And you'll see all these GUIs will gradually disappear. Not doing anything. Say waiting. Setting ghost to equals yes. Huh. Okay, now it's starting. Okay, good. Oh, yeah. It should clear out most of these windows. And you can hit, yeah, enter to exit. Yeah, you can hit enter there. And now all the GUIs should have gone away. If you go to control 0, all you'll be left with are the X terms. So Doug, one thing that might be good to start, I don't know if you Do you have Pamela access, or do you? Okay, so let me see. How can we do this? How can I do this? Do you have enough room on your laptop to start a copy of all the? Yeah, on the laptop that you're using to run VNC. Because what I usually do is it's a two-step process. Wherever I'm running VNC from, I copy, because we can't run VNC while the VPN is running. And without VPN, I can't access Pemla. So what I have to do is, with the VNC running, I download the data from Keck to my laptop, and I upload it from my laptop to Pemla. And for the upload to Pemla, I have to have the VPN running. So you'd have to use an X term on your local machine. That's just a terminal, yes. So if you go to one of these X terms, any one of these X terms, okay. So in a window, in one of the X term windows that's on Keck, we'll have to issue a particular command there. Not in this, but in one of the X term windows that's still on Keck, like that one, yeah. Type C data, CDATA. And let me see. C data, and it tells you a path, right? Okay, perfect. Because what we're going to do is go to your local machine, and which directory are you going to put it into? Okay, so type SCP space minus R, like that, yeah, space. Okay, so what we, yes, first where you're taking it from, yeah. So that should be DEIMOS 6 at keck.hawaii.edu colon, and then that full path /s data 1005 /DEIMOS 6 /2024 sep 30. And before you hit anything in the other window, just do an ls. So you want everything that starts with D0930 star fits. D0930 star dot fits, and put a double quote after it, and put a double quote at the beginning of that. If you just hit the left arrow, put a double quote at the beginning before the /s. Right after the colon. You're right there. Perfect. And then you can hit Control E to get to the end, space, dot. Yes, wherever you want to save it, exactly. It should ask you for a password. I'll put the password in the chat. Doesn't seem to be doing anything. It's not prompting you for a password. That's very odd. And it's the MacBook Air that's running the VNC, right? Let's copy paste that line. Let's copy that line just to keep it in memory. Otherwise, you'll have to type a lot again. Okay, no problem. What's going on? Let's see. I don't understand why it's not letting us. What do you have to do usually? Oh, I see. Oh, I see. I've done it with and without. We can try it without. Because you may also need a backslash in front of the quotes. Okay. Other option is to get the data from the archive later. I think so. So the only other thing you want to get from here is the observing log. That might be good to get now because that won't go into the archive. So for that, again, go to the Polo window. I'll show you how to navigate to go to the local window. Yeah. If you do a CD and then enter, and then LS, and then CD to downloads, and LS. Sorry. One with, and you can rename this if you want. You can move to an MV 2409 and tab, hit tab. It should go all the way to, and do a backslash or U242. Yeah. I don't think it likes the parens because it will need a, in Unix doesn't like the parentheses. It needs backslashes in front of the left and right parens. That's why it's better to do it with a tab. What happens if you hit a tab now? Yeah, there we go. It found it. Okay. So what you want to do is move this to the one without the parens. And hit tab, see what happens. And then put a dot. Yeah. Yeah, that should work. Okay, now do a PWD. Sorry, do an LS, PWD. Okay. So it's in home DEIMOS 6 downloads. That's what you want to copy here. So this one doesn't have any. But there's no stars this time. So hopefully this time it will copy. It's slash home. What does it say? Yeah. PML, yeah. We can figure it out later because these files will stay for another couple of days. So if I can get into the VNC, then I should be able to copy it. I think this has to do. You can Control C out of there. Oh yeah. That's a good point. But then you have to remove all the other stuff. Control E takes you to the end. Everything. You have to delete all that just to the machine. SSH up to EDU. Yeah. See if that allows. Yeah, I think we'll figure this out later. Yeah, I'm not sure why. Could be. Okay. Michael, is there any? Okay. And Michael, the things we need from there that won't go into the archive are the guider images and the observing log. Thank you. That'll then we can just later go to the archive and download everything.